Hi, eighth graders. In this video, I just wanted to show you some more examples of writing equations of best fit lines. So I know we did a few of these last week together. First thing we need to identify is whether the scatter plot has a linear association or not. If it's linear, it means it's positive or negative linear association. We can draw a best fit line. So that's the red line that we have here. Draw the best fit line through the middle of the data points so that all the points are fairly close to the line. And then we need to make sure that we have a couple lattice points. So don't forget, when we go to find the slope, we need 2 points on this line. So when you draw your line, remember to always adjust it as necessary to get some lattice points. Then we calculate the slope using slope triangle, rise and run, vertical change, horizontal change. Pay attention to the scale on each axis when you do that. Don't just count the number of squares. And then we find the y-intercept, where we use y equals mx plus b kind of as a formula. We'll substitute our slope for m, and then we'll substitute the x and y coordinates of one of the points on our line for x and y, and then solve for b. And then once we have m and b, we should check and make sure that those two things make sense for the data and for the best fit line, and then we can write our equation in slope intercept form. So all of these are ones that we did together in class. I want to look at a couple more. So here's one that I'm going to do for you. It has a linear association, maybe a couple outliers here, but ignore those. Linear association for the most part, positive linear association. So I'm going to draw a best fit line here. Try to get about midway through the data. And also keep in mind that I want some lattice points. So I think that probably looks midway through. Lattice points, let's make sure we have a couple of those, which I think we do. So I think right here is a good lattice point. Remember, it doesn't have to be part of the data. Right there. And actually, this one right here looks pretty good also. Let's make sure those are integers. So that's 885. Let's change this one because that's really 2.5. Let's try to get whole numbers here if we can. So actually, that one looks pretty good too. That would be 340. So let's use those. And let's draw our slope triangle using those. So I'm going to go up and then over. My vertical change started at 40, ended at 85, so that'd be 45. And then my horizontal was at 3 to 8, so that's 5. So my slope is 45 over 5, which actually ends up really nice for me. Just a slope of 9. 45 divided by 5 is 9. Now I can find my y-intercept. So I'm going to substitute that slope for m, and I need one of these points. Let's use 340. I'm going to substitute that for x and y. So the y coordinate goes in for y. Slope goes in for m, so 9. My x coordinate goes for x, that'd be 3 plus b. Multiply 9 times 3 to get 27. And to get b by itself, I would subtract 27. And b would equal 13. Let's make sure that's reasonable. So if we were to continue this line, I think we're going to be a little bit under 15, which is good. And our slope was positive. That's a positive association. So now I can write the line in slope intercept form. Y equals 9x plus 13. There we go. Let's do one more. So again, looks fairly linear. Not as close as the previous one, but it's fairly linear. We might have an outlier here. So let's go ahead and draw our best fit line. It looks actually pretty good. Might adjust this just a little bit. Let's go right about there. And I think I have a couple of points that I see. Oh, sorry. I want the points to be blue. So I think this one right here actually looks pretty good. Has a nice lattice point down here. Sorry. Right there. And right here. That one looks pretty good also. Those just happen to be points on the in the data. Doesn't always have to be that way. Now let's draw our slope triangle. So we're going down. This is a negative association. Going down, so my slope is negative. And it looks like I'm at 15,000. I'm going down to 6,000. So 15,000 to 6,000, that's a difference of 9,000. And it's negative because we're going down. And horizontally, I started at 4, went to 9. So that would be 5. So my slope is negative 9,000 over 5, which, if I divide that, would be negative 1,800 for my slope. Now let's calculate the y-intercept. I'm going to use the 0.96,000 just because those are some smaller numbers for us. So y is going to be replaced with 6,000. My slope was negative 1,800. My x-coordinate is 9 plus b. And now I need to multiply negative 1,800 times 9. That gives me negative 16,200. So I'm going to copy this 6,000. Negative 16,200 plus b. To get b by itself, since this is negative, I have to add 16,200. And that's going to give me 22,200 for my y-intercept. Let's look at the graph. If I were to continue my line, it's going to cross the y-axis somewhere in here. That's approximately 22,200, I would say. And my slope was negative. It's a negative association. So I'm ready to write my equation. Y equals negative 1,800x plus 22,200. And there's 2 more examples for how to write equations of best fit lines. So I hope that helps everyone. Take care. Have a great day.